All right, so factoring. It is the base of a lot of things we're going to do in pre-calc and in calc. You got to be good at factoring. So how do I factor this? Well, I can just break it into two parts, and I got to ask myself, what could go here and here that would multiply and make that? X squared. You don't need to do this one. You can just watch me do this one. I'll have you do one in a second. Then I got to say something that goes here and here that makes a negative 8. Well, there's a couple ways. I could go 8 and 1, or I could do 4 and 2. And which one is a difference of 2? The 4 and 2. So I obviously need to use a 4 and a 2. Now, I don't know which one goes where, but I'll just slap them in and I'll guess and check and try something. Now, one's got to be negative, one's got to be positive. This I can figure out because the answer needs to, that's left at the end needs to be positive, so the bigger one needs to be positive. And now, if I think I'm right, I can go through and double check this and go first, x to the fourth. Outside, negative 2x, inside positive 4x, that leaves a total of positive 2x, yay. And the last, negative 8. So nice thing about factoring is you can double check to make sure you're right. One more advanced thing that I wouldn't teach my regular HA classes, but I would teach in an accelerated class like this one, would be that this part here can be broken up. Do you remember what it could be broken up into? I'm counting on a few of you smart kids. What do you think? Yes? X plus and minus 2i. You got it. Because now when I do first, I get x squared. Outside I get negative 2, inside positive 2i, and they cancel. And then negative 2ix and positive 2ix. And then the last, this is the key, that becomes negative 4i squared. And if you remember that I squared is really negative 1, that makes it negative 4 times negative 1, which makes positive 4. So that is definitely a stretch. Don't expect you to be good at that, but I want you to know it. Okay, so there is what you should have been able to do. Factoring. Do you get that? Do you remember that? Okay, factor that one. I'll warn you, it's got a 2 buried in everything. It would be smart to take out the 2 first. I think that's right, isn't it? Okay, and then I can factor it farther. JS, get started. Uh-huh. Good. Okay. Now I'm going to double check it. Outside and inside is usually where the problem is. That makes a total of positive 7x. Whenever you get the opposite of what you wanted, what should you do? Switch the signs. And you could switch the numbers in this case, but it's easier to just say switch the signs. So I'm going to change this to a negative 9 and a positive 2, and there we go. Raise your hand if you had that one right. Okay, you're wrong. Ha! Did any? Oh yeah, I didn't raise my hand because I knew that. Okay, it's close to right. It's just not factored all the way. Does anybody see it? Do you see it? Do you see it? He sees it. What do you see? Yes, because that x squared minus 9 can be factored farther. 2, and then x plus 3, x minus 3. We need a guy like that designing our anti-blindness goggles. All right. The laser beams, remember the discussion we had before? Okay. He just caught it before anybody else, that's all. That's good. I'm not saying you couldn't have figured it out. All right. This one. It's a little trickier because it's got an x cubed at the beginning. Let's see if you can handle it. Some will struggle in vain to try to do this with 2 sets of parentheses, and you'll fail miserably. No, I've got an answer. No, you don't. Oh, how do you start? You get the x out of there, yes. And then I'll have x squared plus 6x plus 9, and then there'll just be two parentheses like that. And then I'll have x, and then what? Plus 3 and plus 3, and then you could kind of combine them together, but this is factored. It's good enough. But if you wanted to go farther, you could say this. But it's not better. It's just different. Yeah, I said if you started like this, see, and had two sets of parentheses, if you did that, and you actually could do this with this, but then you'd have to factor it farther. See, let me show you. Tell me what you got. What did you get when you did the two sets of parentheses? X squared and x cubed, right? X squared and x, sorry, x to the first. Oh, well then. Okay, I get what you're saying. But I was trying to, yeah, you can't like skip the part where you take the x out of everything. That's really important. If you start with two sets of parentheses, it's confusing. If you start with factoring out the x, then you're fine. All right, anyway, that's all I was trying to say. I don't think we need to do more practice of those or those, but this is new. You've never factored anything with 4 parts before. Now, there was a great general a long time ago who was the master at what he called divide and conquer. Anybody know that general? Nope. His nickname would have been Alec. Alexander the Great. Okay. And what he figured out was that if he could divide a country up into parts and take it on one little part at a time, he could take them easy. I'll give you an example. You guys, a lot of you can relate to video games. I can relate to video games. I play video games. I play StarCraft. And in StarCraft, you have these great big forces. And if you can take your big force and take on only half of his army, it's awesome. Because you got like twice as many guys, you'll wipe them out. And then if you could take on the other half of his army separately, you'll win. I'll give you a simpler example. Let's say that you're in Call of Duty. A lot of people play that. If you have a group of 5 people going against one, assume each of the players is all equally good, okay? Because otherwise, if there was like one rock star guy, he might be able to take out 5 players. But let's say it's 5 on 1, and they're all equally good. Do you get how the 5 would just totally wipe out the 1? So if you have a force of 5 on one team and 5 on the other, and they can divide it up into 5 on 1, and then they take on the next guy 5 on 1, and the next guy 5 on 1, you see how he'd totally wipe them out? Whereas if they'd have gone head to head 5 on 5, it'd have been a close match. The point is that if you can divide it up into parts and take it on one part at a time, it's a lot easier. All right, this we want to divide into 2 parts. We're going to take this side, and then separately, we'll take that side. All right, so factor the part in the green box. Just the part in the green box. And there's an x squared in both parts. So you go x squared, and then what's left? X plus 3. And now I'm going to factor the part in the red box. What comes out of both of those? 2. And then what's left? And most people get it up to here, and you're following along just fine. You factor the 2 parts. This part might blow some of your minds. Some of you will be able to handle it, but we'll see. You know, when I look at these, I can say, look, there's a 2 in both of them. So I can pull it out to the front and put it here. Now look at the big picture. There's an x plus 3 in both of them. In this part and in this part, there's an x plus 3. So that x plus 3 can, just like here, can be pulled out to the front. The 2 got pulled out to the front. I'm going to pull out the x plus 3 to the front. And then what's left after I divide that out is x squared plus 2. And now it's factored. Do you get that there was an x plus 3 in both of them? And when there's an x plus 3 in both of them, you can pull it out to the front. Just like that's what you always do in factoring. Find something that's in both of them, put it out in front. I know there's two of them, and a lot of people say, so why don't you say squared? Because when I pulled the 2 out of this, did I say it was 2 squared? No. It was just a 2. Because it'll get used twice, though. This times this makes 2x. This times this makes the 6. So it is really common for people to think this should be squared right here. It is not squared because you pull out a 2 here. We didn't square that 2. We just left it as a 2. All right. And ultimate proof is always this. Can I multiply it back out and get the right answer? Watch what happens. First, x cubed. Ever seen that before? I'm going to use red to emphasize the point since I've used the other colors too much. Outside, 2 times x, 2x. Inside, 3 times x squared, 3x squared. And the lasts, 3 times 2. It works. You get that? All right, I'm going to show you one more like that, and then I'm going to have you try one. And this one, I'm still working on. I'm going to pause for a second because somebody at the door again. Did somebody just catch me on that? God, twice in one day. That's impressive. All right, x squared comes out x. X plus 3. And then over on the right side, you might think to just take out the 8. But anytime there's a negative on it, take out a negative 8. And then I'll have x plus 3. And the good part is these match now. If I had only taken out a positive 8, then they wouldn't match, and you couldn't go any farther. All right, so now there's a x plus 3 in both of them. So that goes out to the front. And then what's left over, technically I'm dividing by x plus 3 when I'm bringing something out to the front like that. And then this cancels, and this cancels, and this cancels, and this cancels, and my answer is what's left, x squared minus 8. And if I wasn't sure that was right, what could I do? It is factored. I could FOIL it, yes. I could FOIL it. First, outside, inside, last, and it would give me each part. That's x cubed. This is negative 8x. This is 3x squared. And this is negative 24. Yay, it worked. Okay, I want you to try one. Try that. All right, so do you have a 4 factored out of everything? Did you even notice that? Some of you noticed. That'll make it a lot easier. X cubed minus 2x squared plus 2x minus 4. Now it'll be a lot easier. If I take the 4 out and then go, okay, divide and conquer. Divide right down here. This part will have an x squared that comes out. And then what'll be left, x minus 2. And then this part over here will have a 2 come out, and it'll have an x minus 2. Notice there's something in common, the x minus 2 and the x minus 2. So the 4 is in front. The next thing is an x minus 2. And then when that gets pulled out, what do I have left? This and this. X squared plus 2. Did anybody get it to that conclusion? One person. Nice job. 2 people? Now, if you have this answer except the 4 is multiplied in somewhere, you were close, but you needed to notice that you could get that 4 out of there. So why don't you give me what the answer was, Mr. S. in the back, when you had it multiplied in, what did you have? Yeah, and that's the part where you might have been able to save it at the end and notice, ooh, there's a 4 in both of them, and pull it out there. Okay? All right. Did anybody else get it to this part? That's really close. All right, good. So, one more of these. Try this one. If we can get 3/4 of the class to get it this time, then I think you're ready to start your homework. There's no number to pull out. Ah, yes. Before you struggle for a long time in vain, You can get an X out of this whole thing. Then divide and conquer. If there's any secret to really hard problems, it's noticing there's something in all of them and getting that one thing factored out to the front. That's called the GCF. The easier problems don't have that, but if it's a hard problem, it's probably got that. Did anybody get it to the end? Ooh, yes. And that is about 3/4 of the class, so we're good. If you struggled with this more and you want more help, I will gladly show you one-on-one. The problems tonight, there's 12 of them. 6 of them are normal factoring. They're not super easy, but they're not this hard. And 6 of them are this divide and conquer kind. Okay? So your assignment is right here.